Hello everyone. Today I'm going to be talking about the attempts of periodic classification by scientists that were attempting to make the periodic classification. Alright, let's get started. First of all, I'm going to talk about how the elements are classified. So elements are classified by arranging the elements so we could understand their properties. And we organize the elements like according to their properties, and we also have to categorize them according to their properties, metals, non-metals, and so on. The classification, its definition is categorizing elements into groups based on similarities and differences in their properties. Like I said, whether it's metals or non-metals, noble gases, depends. I'm going to be talking about 4 scientists that attempted to make periodic classifications. First off, we have Dobronier, and there's John Newlands, and Henry Moseley, and Mendeleev. We have Dobronier. He classified the elements into groups of 3. Not groups of 3, like it was 3 per group, 3 elements per group. So he listed them above each other, like 1, 2, and 3 above each other, and he got the average of the atomic mass of the first and third elements, and that gave the atomic mass of the second. In like that order, basically. So for example, right here we have the Li element. It was 6.9, and the K is 39. So if you get the average of those, it equals 23, which equals Na, which is the second element. However, this wasn't the best method because not all elements followed this method. Some elements would not be able to follow this method, or like have different calculations. Second, we have John Newlands. He made the groups method, but it was in 8s. So he was just like Dobronier, but he made it in 8s instead of 3s. First off, he arranged them in an increasing order of atomic masses. In the modern periodic table, we use it according to the atomic number. But here, John Newlands, because it was just the beginning of his attempt, he arranged them according to atomic masses. And number 2, every 8th element resembles the first. Like every 8th element of the group resembles the first element, or it's just like it, basically. And third, the problems that the method faced, it was invalid until the Ca element. So basically it reached a certain element, and it was invalid. You cannot use that method anymore. And number 2, the CO and Ni were placed in the same position as the halogens. And that isn't right because they are very different. They have very different properties, physical or chemical. They have different properties. And lastly, it was called Newland's laws of octaves. Newland's law of octaves, because octaves also have the same thing, musical octaves. The notes, they are 8 notes usually. So the first note always resembles the 8th note. They're like each other. And now we have Mendeleev. First off, he made the arrangement in the simplest and most efficient way by grouping the elements. And second, he laid the foundation of the classification which we use today. The foundation, which means basically the shape of the periodic table that we use today, he laid that foundation. He made that foundation for us. And number 2, the elements discovered back then were only 63 elements. Of course, right now we have many more elements that were discovered, but back then there were only 63. He wanted to respect the physical and chemical properties. So to understand the chemical ones, he made elements react with standard elements. He got elements that weren't standard and made them react with standard elements. He chose 2 specific elements, which were hydrogen and oxygen. He chose those two specific elements because they are reactive and they are found readily in nature, and they form compounds with most elements. And number 2, he wrote the physical and chemical properties of each of the 63 elements on cards, then he arranged them. He arranged them according to the properties. He arranged them. He arranged them according to the atomic masses. The 63 elements, he wrote each element. He wrote the physical and chemical properties for each and every element on a separate card. And we're continuing on Mendeleev. He started by arranging them in increasing order of their atomic masses. As I said before, he was arranging them in atomic masses, but he was arranging them in an increasing order. He, however, observed some issues while he was arranging them. He observed that there were empty spaces, and those empty spaces, he assumed that they were elements that were not yet discovered. And number 2, he saw reoccurrence of physical and chemical properties while arranging these elements. And 2, he came up with the periodic law. It's the properties of elements are periodic functions of their atomic masses. The periodic law, that's the periodic law that he stated. So in brackets, the properties of elements, that means the physical and chemical properties. They're periodic functions, which means they occur at regular intervals. And of their atomic masses, which means they have an increasing order of atomic masses. When elements are arranged in the increasing order of their atomic masses, they have similarities in physical and chemical properties at regular intervals. That's the meaning of the periodic law. And lastly, we have Henry Moseley. Henry Moseley modified Mendeleev's periodic law, and he arranged the elements in atomic numbers, which is what we use nowadays, and it's called the modern periodic law. So he used the foundation that Mendeleev created, but the difference is he used atomic numbers to arrange the elements in the periodic table. Thank you for listening.